Okay, I was thinking about this. You have a bottle full of water and you put 3 little holes. Then the water obviously is going to exercise the pressure down the bottle. There's a top here. So it has no other option than to spurt out the holes. How does it spurt out the holes? The one with the highest pressure is going to go further due to the force of gravity. The next one is going to go a little bit less because there's lead head of water above it, exercising pressure against the surface of the water right at the hole's level. And then we have the one with the huge pressure going down. So, on the same token, after observing rainbows through a prism, I have a lot of photographs about it, I was thinking the part of the light that has, or the component, the red component of the light that has the lower frequency is going to fall with less, not gravity in this case, is going to go with a less force wherever it goes due to what other part is an electromagnetic force? In the electromagnetic spectrum we have the electro and we have the magnetic. If it falls, there is a pressure. It's going to be electrical. It's already moving. The electrons move, the photons move. There's some movement from high pressure to low pressure. So what we're seeing here is that I think the magnetic force is the one that drives the frequency to perhaps change from position. And so what I did, in other words, the higher the magnetic field, then we see a higher frequency, or the other way around. I still don't know because I'm an ignorant at it. But I think if we change the magnetic field, we would be able to change where the frequency of one of the components of light is at, or various. And if we keep doing that in a rotary sort of fashion, we would create an induction, perhaps. That would be very interesting to study. That's what I'm trying to. I finally got to the point where I can express myself, and I still don't know if this is the right term, an electromagnetic field. I don't know if the higher frequency gets more affected by an electromagnetic field than the less hot one, which would be the red. The hottest is the blue. So I have to look into it. But I'm so excited that I can express what I'm looking for. So in other words, I'm going to take the light and I put it through a tube that has mirrors and it rotated, okay, and I could actually change the position of the tube that has the mirrors in it and make the light come out at various points outside the actual rainbow spectrum that I would get on the wall. So my next plan is to get a glass tube and coat it with silver nitrate and some sodium, and then not sodium metal, and then some ammonia, make a mirror inside the glass tube and then see if I can get it to rotate. However, yeah, the rotation of the rainbow carries at least 1.5 inches to 1 inch in between each turn. But what I would like to do is condense that rotation to the point where it can't come out. The light can't come out. What would happen then? Where does the light go? It keeps going around and around and around. But that electromagnetic field has to increase somehow. And how does it affect the rest of the light? So that's what I wanted to do.